Hello friends, welcome to TechAG YouTube channel. Friends, in today's video we are going into deep of Kubernetes operator concept. Okay, so here today we will discuss about why operator, what is operator, and we will also compare it with Helm and Kustomize. And here we will also see how we can get operator, pre-built operator, and at last we will also see how we can develop our own operator. So here basically I will show a sample demo operator development environment by using SDK on RHEL9 based system, and also we will deploy it in our Kubernetes cluster. Okay, so basic question is why operator? And think like an operator automate the full life cycle of a complex application by encoding a human engineer's runbook, also called SOPs, directly into the Kubernetes code. Okay, so it moves you from basic deployment to self-healing auto-scaling infrastructure that manage itself based on your specific business logic. Okay, so that is the overall motto of operator. So it manages everything from initial deployment and configuration to ongoing updates, scaling, failure recovery. It means day-to-day operation or day-to operations too. So it essentially acts like a 24/7 virtual site reliability engineer. Okay, so that keeps the application in its desired state without much manual intervention. Although it's not 100% correct, if you also deploy this Kubernetes operator, then after that also a human SRE will be required, but human SRE role will slightly change. Okay, so then you might question what then human SRE will do. So that's why there is a basic comparison, like what traditionally SRE engineer are doing. Also they both exist together. Okay, it does not mean if operator SRE will come, then traditional SRE has no roles, just their role will change a bit. Okay, so like previously like traditional SRE were doing the manual scaling or auto scaling by using HPS. Okay, or horizontal pod auto scalers. Okay, also they are using the vertical auto scalers. Okay, but that was rare. But here what modern operator era SRE will do, basically they will define auto scaling policies in CRD. Okay, so we will discuss what are the CRDs. Okay, so upgrades, like previously they are doing the midnight maintenance upgrade. Okay, in Windows also they are doing the rolling updates, but usually those are happening within the Windows, you can say maintenance window. But here it orchestrates rolling updates by operator logic itself. So it we can also schedule, also define those logic, like when it should happen. Okay, because everything here it's writing in deterministic nature. Okay, nothing is going to happen automatically. It's not a AI robot, you can think. Okay, so here we define our logics within the operators. Okay, so these are just slight changes. Okay, like deployment, earlier we are using the run scripts or pipelines. Now operator itself ensure desired state continuously. So all the things that we are doing the manually, just we here operators come in picture to develop a logic for that. Okay, and do it from itself. So we define the logics. Now modern era SRE will define the logics and change in logic only, you can think that. Okay, so now question is, I guess you have now idea what is Kubernetes operator. So a Kubernetes operator is a method of packaging, deploying and managing a Kubernetes application. Nothing. Okay, which application? It might be your microservices based applications. Okay, so basically it knows the specific operational logic of that complex application that you have developed. Like if you are using the Oracle, then how to do the day-to activity, like how to do the auto patches, how to back up the database, how if you are using Kafka, then how to recluster Kafka nodes, how to recover from the bad changes. Okay, all these things we will define inside the operator logic, that is basically known as consolidation logic. Okay, so basically Kubernetes operator relies on continuous reconciliation loop. Okay, so you can think as it's a basically a custom controller. Okay, so here we are developing our own type custom Kubernetes controller. Okay, so it will watch the cluster state like events, CRDs, and it will react automatically to the changes. Okay, so you can think like an equation, like operator is nothing but custom resource definition plus a custom controller. Okay, CRD plus custom controller. So what is CRD? You might have question, what is CRD? So basically CRD made from CR plus D. Okay, CR is the actual object or instance. Okay, so if you know the ops concept, then what is the object, then you can definitely relate from that. If you know about Kubernetes object and you have taken my very first session on that, then I have told you what are the objects. Okay, so basically in every deployment or every stateful set, okay, we declare a object. It's known as kind also. So basically CRD is a combination of those objects, and when we register those objects with the Kube API server, okay, then it's called a custom resource deployment. You can say that, yeah, custom resource definition. Okay, so custom resource definition. So here we define a kind object in the Kubernetes API, like kind may be a Postgres or your custom application name, so like your application name. Okay, so because here we are developing from scratch. Okay, so when we register with the Kube API servers, it became CRD. Okay, so it's a one component watcher, like it's basically watches the API server for any events related to the kind or our object, like here our application, like that we defined there. Okay, so reconciliation loop, this is the heart of the operator. So it constantly compares desired state with actual state. Okay, so like the actual state is what is currently running in our cluster, and the desired state means what the user wrote in YAML, like we should maintain the 3 replicas, and also they have mentioned some affinity rule will be there. Okay, so that all should come in desired state, that should match with actual state. Okay, so who will confirm it? This is the reconciliation loops task. Okay, and then action, if they don't match, the operator execute code to fix it, like it will trigger a database recovery, or it can delete unwanted changes, okay, to make it in the desired state, to make this desired state and actual state same. Okay, so main objective of this reconciliation loop is to make desired state equal to actual state. Okay, so that desired state can become actual state. There should not be any difference between these two. So let's compare the basic difference between Helm, Kustomize and Operator. So basically, if you know, Helm is just a package manager. So and Kustomize is used for the configuration customization, but operator is used for the complete application lifecycle automation. Okay, so complexity of Helm is medium, Kustomize is very low, because here we just customize it with some parameters changes. But in operator it's very high, because it requires the Go language knowledge and also the Kubernetes API knowledge. Okay, and Kubernetes all the components knowledge in deep. Okay, so that's why its complexity to develop operator is very high. Okay, so templating in Helm, it's template based and it's possible, and Kustomize, no, it's configuration based, so not possible here. But in operator it's based on code based logic. Okay, completely code based logic. Here we can also use Helm based operators or Ansible based operators. Okay, but overall the basic standard to develop operator is by using the Go SDKs. Okay, so lifecycle management, it's a basic install upgrade. Okay, and Kustomize has no lifecycle management, because it's just a configuration used for the changing the config. Okay, and but operator has advanced self-healing and scaling lifecycle. Okay, so use cases, it's basically used for deploying the app one time, and then after that a human operator will operate those applications manually or by using the Kubernetes features. Okay, basic features. And Kustomize is for managing the configuration variants, and operator is just for running the complex systems. Okay, so if you are in a product based company who is making multiple who is developing the multiple microservice based applications and deploying in Kubernetes, so I am damn sure they are also working parallelly in operator development part. Okay, so mostly it's operator development task will happen in product based companies. So, and at last, one more component is where admissions webhooks. Basically it intercepts API request to validate. Okay, so if there will be the bad YAML, then it should reject that, mutate, automatically inject sidecars before they hit the etcd. Okay, so how we can deploy an operator? So basically in most of the organization we don't write like SREs or any DevOps engineer don't write complete operators. Okay, because there are separate teams for developing those, and those teams are very has very domain specific knowledge of that applications, and also Kubernetes APIs knowledge, as I told you. So those teams are working in developing the operators. Okay, so in most of the cases we have to just use the pre-built operators. Okay, if you have to develop the operator, then there will be the main three things. So basically we have to encode domain knowledge, how to run an applications. Like if you are working on developing the database applications, so then all the database applications code is specific, like if it will be based on microservice, it should be based on microservice architecture. Okay, so their domain specific knowledge will integrate with the Kubernetes, okay, APIs and Kubernetes components, and there we define rules and logic. Okay, so we will also see in upcoming after some times like how we can do that. Okay, practically. So you can implement continuous decision making in reconciliation loop. Okay, so like if we understand this, like here, if replica is less than desired, then it should scale up. Okay, if pod fails, then it should recreate. If upgrade then do the rolling update. Okay, so all these things will happen automatically. We will define the logic of that. Okay, so this is a deterministic automation. It means rule based system. It's not any AI system. Okay, it cannot run from itself, it cannot learn from itself. Okay, so here many companies are also working on that part too. Okay, but operator, till now operator did not have that features. Okay, so be very clear, it's not a AI system, it's a deterministic automation system. Operator is a deterministic automation system completely. So for developing operator, as we discussed, we mostly use the Go programming languages for that. Okay, and we implement it with the some SDKs. Okay, so basically SDK is a toolkit that support multiple approaches, like by using Go, Ansible or Helm based. Okay, so Ansible is also way to implement operator logic system playbooks, and Helm can also, by using Helm we can also implement operator. Okay, by using Helm features. So there is a quick comparison between these pros and cons and usability. So basically Go operator core technology is Go, and if we develop Ansible based operator, then core technologies will be Ansible there, and if we use Helm based operator, then obviously core technology will be Helm. Okay, so here we can build it with the operator SDK or code builder. Here if we use Ansible operator, then we have option with operator SDK. If we have Helm based operator, then we can also use the operator SDK. So operator SDK is the common way to develop that. Okay, so what it does, it's here when we are using Go based operator, then we have full custom controller. Okay, but if you are using Ansible based, then we have to be basically based on the run, we have to run the playbooks or roles. Okay, there. And if we use the Helm based operator, then here we have to reconcile, we have to write in by using the release, and reconciles by using Helm charts itself. So most of the flexibility goes with the Go operator, and then after that Helm operator. Okay, but if you are configuration heavy, then you can also use the Ansible based operator too. Okay, because in most of the production cases we have to be very deterministic with the configuration part. So in that case you have to go with the Ansible operator, although it's not a very flexible. Okay, because flexibility is not the key in production environment of the very sensitive environments like banking and telecom sector. Okay, because they require the most deterministic output result. Okay, they don't want the flexible result, they want deterministic result. Okay, so don't just see like it's a Go operator is very flexible, then we will always use and go with the Go operator. No, it's not the case. In reality, most organization, okay, critical sector, go with the Ansible based operators. Okay, or Helm based operators. But if you have the development, a large development team, if you are working a very big product based company, then obviously they will go with the Go operators. Okay, here as I told you, complexity is high, low, mid. Here it's low to medium in Ansible, and Helm based operator is a medium. And execution model is here continuous reconciliation loops. It's basically an event triggered playbooks, and operator SDK which is reconciled by Helm releases. Okay, and state handling, it's a fully programmable, it's a limited, and it's limited to Helm model. Kubernetes awareness, it's a very deep awareness. It Ansible operator has limited awareness. Okay, limited moderate, sorry. and Helm has also moderate. Okay, performance like in Ansible, you can think like it's not made for performance, so it has lower, but Go based operator has very high performance. Okay, and Helm based operator has medium performance, and it's best for complex product oriented systems, and it's best for automation tasks, and it's best for chart based applications. Okay, so all have different use cases. Okay, so from where we can get the existing operator. So we can get existing operator by using the OperatorHub. It's basically open source. Okay, but here if you have to push your operator, okay, there, then it must be approved by their team. Okay, you cannot simply come here and post any operator there. Okay, so if you are interested in developing operator, okay, so write those application specific operator there and post in their GitHub. Okay, and if they will approve your operator, then it will come inside the OperatorHub. Okay, it's not like a Docker registry or GitHub registry. Okay, because it's a public platform. So to maintain the security, they will require the same. Okay, so here like these has multiple operators. Okay, as per your requirement, you can download those operators and install these operators. Okay, like the same OpenShift has also their OperatorHub. Okay, OpenShift has itself OperatorHub UI, and from there you can install Helm based operator, Ansible based operators too. Okay, and GitHub also helps, you know that, but in GitHub you can also like upload your operators. So like in today video we are going to use the GitHub container registry for the same. Okay, because it's our demo application, we can't post on any public platform like OperatorHub.io. Okay, so just it will walk through with all the concept you can think. So how you can install operator? It's very simple. You can directly download their YAML files, and if you have internet connection, then you can directly apply that operator.yml file. It will just apply in your cluster. Okay, but it will require the internet connectivity. Okay, so make sure if you are working in private environment, then there should be some proxy should be configured there. Okay, so you have to check the proxy settings before applying that. Okay, and the same we can use by using Helm install my operator and providing the chart name. Okay, so basically operator run inside our cluster, and okay, we can get this like by using kubectl get command. Okay, so without wasting time, let's go with our video. So how we can build operators? Basically I told you like we can use the operator SDK, because it's the universal way to develop the operator. Either it's a Helm based operator, either it's a Go based operator, either it's a Ansible based operator. Okay, or we can also use the cube builder, but in our today's demo we are going to use the operator SDK, which will be the Go based. Okay, so there we will generate CRDs, controller and project structure. Okay, so here in my setup we have the RHEL 9.7 and cryo as this system is here. You can check that. Okay, so this is Linux Linux machine, RHEL, basically RHEL 9.7, and okay, so you can see that OS releases here, also here from here EL 9.7. okay, and also I have this same node is also part of our Kubernetes 3 node control plane and worker plane cluster. Okay, so here as I told you, all these my nodes are working as a master and slave both at the same time, because I have untainted my these three nodes. Okay, this is my local laptop setup. Okay, this is node 1 is my physical machine. Okay, and node 2 and 3 are the VMs. Okay, so here we need to first I am showing in my setup. If I am using Ubuntu, then we have to just change this DNF with the your package manager, that is the apt. Or if you are using any other Linux distributions, okay, like you can, then accordingly you can use those package managers. Okay, like if you are using Surface, then there will be Zyper will be there. Okay, but overall structure will be the same. Okay, so here in my case I will go with these. Okay, so I have already installed all these things, but here I am showing just to make a concept anew, so that how we can proceed with the development part. Okay, so similarly you have to install the Podman, Docker, Go language and Git. These all are the prerequisites that should be present. Okay, so it's saying nothing to do, but if you are doing the first time, then it will definitely install those things. Okay, and then we have to export these proxy settings. Okay, and these SDK settings variable. If you want to set up for permanent purpose, then you have to make entry inside the bash RC file. I know you if you have watched my earlier video, then you have the concepts. Otherwise, if you have some basic Linux skill, then you can simply go through with that and you can understand properly what I am saying. Okay, let me commit those changes, otherwise it will. Okay, so all these things are like inside my this repository itself, so you can go through with that and you can basically understand all those things. Okay, so just here I have already made the permanent entry, so here just I am exporting those things one more time so that you can get. And then after you have to install this operator SDK by using this command simply. Okay, so I have operator SDK already, and here just I have done like around 1 hour ago. Okay, because every time, anytime during this, it might some errors can come. Okay, so I cannot take any chance during the video. Okay, so that's why I have checked all these steps. Okay, so you can just go with that. Okay, so now we will show and demonstrate the complete flow of building an image with Podman and how we can upload it in GHCR GitHub container registry. Okay, so basically the image that we create by using Podman, it's OCI compliant. Okay, so we can upload there. Okay, and then we can put there and we can pull it and use it. Okay, so first of all, let we create the directory here. So let's start with project. Give the name like Kubernetes Operator Labs. Okay, and then we are inside the Kubernetes Operator Labs directory. Okay, now we will basically do two main things. First, we will initialize SDK. Basically, it's a Go based, as I told you. We have completed all the prerequisites for the same. So we will initialize that. So it will create the project skeleton. Okay. So here, let me give it a name. So my operator initialize and also tell us the further comments. So let me get this runtime. Also go td to update the dependencies. So it will download multiple dependency. If it's your first time to like create the project, then it will download the multiple dependency. Otherwise, in my case, I have already completed multiple projects here previously, so that's why it's not downloading any dependent module here. Okay, because all modules are up to date in my system. Okay, so fine, now we are ready to create the API. We can now run this command, and here I will give the defined object name tcaps. Basically, sorry, to see clear the screen. Let me come here. Okay, so here I will give the name like take application. Okay, so version will be 1, group will be web. Okay, so let me do that. Okay, so it's saying fail to create API, unable to run post scaffold task. Okay, so let me, so its Go version is 1.24.6, Red Hat 1.246 CL9. Okay, so we have to, like here, let me show you this is the basic skeleton. Okay, ls-lrth, so that you have better visibility of that. Okay, so here you can read the readme.md. Okay, to understand all the things here. So basically, okay, and you can get all the things like here running on the getting started, all the things, and here you can go there, and kubectl here it's shown you how to you can run on cluster, how you can basically install the CRD, how you can undeploy the controller, and all the things are here. You can go through with that for better understanding. So all the things before when SDK was not developed, so we have to do the manually, but SDK has done a ton of our work. Basically, we have now a sample deployable unit. Okay, we can simply what we can do, just we can generate the manifest. Okay, and we can run it either locally, either we can push it into any registry. Okay, so first of all, let me go with the important file which is related to that is the make file. Okay, so here as we have version, so operator SDK version is one here. This is the very important file. So if you are getting any issue related with the compatibility, okay, so earlier just here we get the issue like during the like this. Okay, like this command. Okay, so all the things are resources already. Okay, so API resources are there. So now what we can do, so we have all the things ready made. Okay, Now we can just go here, like we can update the Docker files or image. We can just go inside the internal, and here we have something called controllers. Okay, inside the controllers we can here define our logic. Okay, so this is the our main reconciliation engine. You can think that it's basically a Go, so we have chosen the Go. So here we can write our complete logic. Okay, so let me go there. Okay, okay, so here you can see that it's a package it's just importing the Go packages. Okay, and controller runtime, basically Kubernetes controller runtime, and this is the basic construct, and these are the basic building block functions. Okay, nothing more written here, but as per your requirement you can write here. So it's a very application oriented. Okay, so if you have a application, then as per your application you can just develop the logic here for the day-to operations. Okay, so here these are the here also so test.go is here. Okay, so here, sorry, it's vi. Okay, so here it's also a package controller. Here you can define your environment variable, basically. Okay, as per your application and as per Kubernetes APIs. Okay, so let me go from here. So these were the heart. Okay, because all the logic will go there. Okay, and also there is a config file and bin file. Bin file is basically encrypted file, and in API you can define your applications metadata like thing. Okay, now you can change it. Okay, we have just done it earlier. Now you can just use the make install command. Okay, and you can locally run this project. Make target. Okay, so we have not generated the manifest. Okay, till now. So let me here, like it's told you, like you can use your you can write edit controller. You can here also if any custom API you are writing, then you can also write there. Then you have to make the manifests. Okay, so let me generate the manifest file, and then we will run the make install and make run. Okay, so we are also missing some one more important command here. So let me wait, what is the okay, so there's make generate. So no rule to make target generator stops. Okay, so now it's a bit confusing why you are getting this. Okay, so let me check where we are. Okay, sorry, so we have to go inside the why that was happening, because it should read the make file. Make file is the most important one file. Okay, so let me do the make generate first. Where we are right now, ls here, make file is here. Okay, so now make file manifest error. Make generate okay, we are just missing the spelling, that's why. Make manifest, make install, the installing tools v12. Okay, so it's not compatible with basically controllers tools v12. Okay, so that's why we are getting this error. This was very common. So where I told you all the configuration will reside inside the make file. Okay, so it's a controllers tools. Okay, so let me find controllers. Okay, sorry, it's saying pattern not found. Controller underscore version. This is 127 in test. Let me check the version. Controller okay, in small case I guess. Yes, in small case it's multiple. Okay, so let me controller chain controller underscore actually I want to find the controller version, controller tool basically. Okay, so here it's here controllers, it's in capital, that's why we are not able to get. Okay, so here just make it to insert, going to insert, we'll use the 16 or 17 is compatible with our version. Okay, so now let me try to use mention. Okay, it's actually we need to also clear the some cache files. Okay, so I will do nothing, just I will copy paste this to Gemini or any tool like ChatGPT. It will tell us exactly what files we need to delete. Okay, just they are very capable now, at least in suggesting. Okay, I know that I need to delete some files, but I don't know exactly name. Okay, I have already changed that version. Now we have to clean the cache, mode cache, I can clean our build cache, and yeah, then go mode td. So okay, go mode td to update the dependency. Okay, so now it will download the required dependency. Okay, related to our tools version. Okay, so now we can do. Okay, so here okay, we no use a vendor, like we do the make generate. Okay, Now this time I hope it's compatible. Okay, so again by this time it's saying it's again just why it's doing. Let me check why it means something we have not deleted from cache. It's already 17, controller tools version is 17. Okay, let me match this version with our installed co version. It's very important. Okay, go version. Okay, go 1.24.6. Go 1.24.6. The combo is the problem. Go 1.2 is very new. 1.24.6 is very new. Controller tool. Go type. Internal go 1.2. So safest. Go 1.2 and controllers tools version. Okay, so let me here we have go version this 1.24.6 is basically latest one. So either we can also just here we can okay, let me clear the beans I guess, because earlier this version was working fantastically. Okay, with our system. Okay, so let me wait for moments. So these are the parts. Dependency is the most toughest thing, I think. Okay, so in any environment, okay, so don't worry, these are parts. Hope we will recover soon from this error. Okay, so now again I will run the same. Okay, so make generate is worked flawlessly. Okay, fine. So make generate is working. Now we can use the make install and make manifest first of all. Okay, so create okay, so it's working fine. So we can either run locally or we can use the make run. Okay, make install and make run to run this in local system. So wait for moments. I guess this time we will not get any error. So in real time we are going to face errors. Okay, so it's created. Okay, it means it's working fine. Okay, so our CRD is working fine. Let me run this. Make run. So it will basically run locally in our systems. Okay, so wait for moments. We will also see how we can build this with Podman and upload in our private registries like GitHub registry. Okay, because it's not ready to be supposed to be uploaded in any public registry, because they will check like what you have developed. Okay, for which application you have developed, then they will approve or reject. Okay, so that's why we can't go with the public one. We will just I have to just walk through that with the complete process, so that you have a deeper idea, and if you are a developer then you can start developing from here. Okay, so now it's live. Let me check in another terminal by using kubectl get CRD, and what was the name of our application? I don't remember. Something was application was, I know that application was there. So brief-i application. Okay, so here take applications web tech.io. So our custom CRD is running fine in our system. Okay, so it's running fine. So let me here close these two. Okay, so now I have stopped that. So we will go with the second one, how we can simply just so yeah, these all are completed. If you have like, you can upload it in any registry, private registry. Okay, although you can upload it in public registry because it will not approve. So let me build by using the podman. Okay, and I will give the name hello operator v2. Okay, from v1 to v2. Sorry, there. Control C, clear. Okay, so let me use the podman build -t. So here I will give name v2 and I will give name hello operator v2. Okay, no context directory and no container file specified ls here. So give the, like here we have a Docker file, so you can see that. So you can go with that. So basically all these Docker files not have much of information, you can see that. But this is just for the demo one. Okay, so we'll use that same demo one. Okay, so here now it will create. So we have not specified the Docker file locations. Okay, so that's why we get the error. So it will take some time. Here you will see that in our packages our third package will come. I guess no, package name is same as hello operator, so it will come inside here version 2. It's a version 1. So another version of this will come here. Okay, supposed to come here when we will push that to here. Okay, right now just we are generating. Okay, so now, so I guess if you have followed me earlier, so you know that for uploading in your GHCR registry will require the path. Okay, so let me, I have a path. So let me log in inside my path and I will regenerate that. So wait for moments. Let me send code by mail. Okay, so wait. So it will ultimately require a path to okay, so I will give a name it to operator path. Okay, so I will regenerate the token again because I have. Okay, I will generate for 30 days. Yes, copy that, submit that. You can copy it too, but I will definitely going to update that, regenerate that token again post completing this session. Okay, so I will make a variable which is like path variable, and inside that I will put my access token. Okay, let me env. Okay, pat is here. Okay, fine. Now let me try to log in. Okay, so we have built that. So we can check that by using this command, by using podman images. Okay, so here we have, earlier I have made the version 1 and now we have version 2.2. okay, exactly same size, 54.7 MB, because we have not changed anything, just we have changed the version name here. Okay, so now let me log in inside my GSS GitHub registry basically. Okay, so login succeeded. Now we are ready to push the same. So here we can push that. Okay, so it's basically we push in our GHCR registry. So here let me show the packages. Version 2 will come here once upload will come complete. Okay, so now we can pull this from our GitHub container registry and we can use that. Okay, so wait for a few more moments, it's taking time because its size is 54 MB. Now click on view and manage all versions. Okay, still version 1 is here, present here. Okay, so writing manifest to image description. Okay, it's completed there. Okay, so now version 2 is visible here. Okay, so now we can just pull this image. So our developer work is completed. Now developer work is completed. Now operation engineers or DevOps engineers can pull those images and can use that. Okay, so push is completed now. So we have checked how we can locally run that. Now we can just use the make deploy. Okay, and we have to provide the image. Okay, so sorry that. So we can use now the same. So here let me come and I will now use version 2. Okay, so now we can choose kubectl get namespace. Okay, so here cube operator labs system namespace is here, which is created around 30 seconds 13 seconds ago. So let me check is pod, any pod is there. kubectl get pods k-name namespace. Okay, so one pod is here, but here it's saying error image pool. So let me describe that. kubectl describe kubectl describe pod and provide the namespace. Namespace is Kubernetes Operators lab system. Okay, so what is the error? Successfully assigned error image pool, image is emerging, proxy, image pull back, backup pulling image pull backup, pulling image, fail to pull image. Okay, basically it's able to get there, but it's basically same using name or password is unauthorized. Okay, so it means here let me manually try to log in our containers and provide the password here. Okay, I have not saved that. Again, I need to regenerate the token. Copy that. Update token. Okay, so let me paste here. Okay, so login is successed. Okay, so let me go there and let me delete the resources. kubectl delete pod namespace is okay. So once again, okay, so now it's in container creating stage. Again, error image pull. Okay, so let me check why we are getting this error. Let me once again describe this pod. So these are the very realistic errors. Okay, so don't worry about that, like you don't have to panic. Okay, this time, so again the same fail pull image. Okay, so what I will do, I will manually pull this. Okay, so it's basically trying to basically take this from the secrets. Okay, so got it. So what we can do that we can just here we can manually pull it. Okay, so I will use the pod and pull command, okay, to pull the same, to bypass the secrets requirement. Okay, because it will this time this will use. Okay, so let me use the podman pull to manually pull this image. Okay, one more thing was there here, a bit tricky here, like yes, I earlier also faced the same. So what was the problem? Okay, so here it's actually, if you notice that it's just trying to pulling from this is the file, this we can do and pull it manually. Okay, so let me podman pull this one. Yeah, so we can able to pull it, and one is like here you can see that image pull this one. Okay, so now this cube airbag proxy is actually changed, the location is changed. Okay, so let me, you can just search it in Google, like here in Gemini, where to find. Okay, so here you can just do that, and so here at this location it's actually configured in our itself tool. So operator and instead of this we can use the Kubernetes community registry image. Okay, so let me go there and do the changes. So here you can see that this is taking the image from here. So what we can do, we can just use the community registry. Sorry. Okay, so now I guess this time issue will resolve. Okay, so we'll use kubectl get name space kubectl get pods. Okay, fn. Okay, let me delete the old one. It will also automatically delete once this will run. Okay, because that was the beauty of operator. Okay, operator also used for the cleaning up the resources. Okay, so when we just created, automatically it's a built-in logic when you use SDK. So if this one will come in running, then automatically it will delete. Okay, so wait for that. It's in container creating stage. So let me describe that. kubectl describe to see the things what is going on there. So kubectl describe pod, and let me give the pod name. Okay, and namespace name is Kubernetes Operators lab. Okay, so it's pulling. Basically it's running currently in normal stage. It's pulling from registry kt.io, kube builder, kube rollback proxy. Okay, so after that it will, yeah, it's again error. Why error in is pull? Okay, so it's try to use that one, so that's why. Let me check each one is running or not. Git pods, yes, 1 out of 2 is already running. It means we have solved, like out of 2 container, 1 container is running, although 1 container is not running. So what is the basic solutions now we have? So we have manually pulled. Okay, now we have the image. So when we search the format image, okay, so version 2 is here. Okay, so we can specify basically to use this local image. Okay, for now, because we need to configure the secrets. Okay, so why we are facing this problem? Because we have not configured the secrets and it's enforcing us, okay, to provide the secret. Okay, that is the only problem. Okay, okay, now let me redeploy one more time and do this copy paste. Okay, again I will go here. Okay, so now you can see that what we have done. Just we have pushed it into our cryo. Now it's running. Okay, so here kubectl will describe ports. Okay, kubectl describe ports and namespace. Yeah. So unable to retrieve or token invalid username password. Error means full. Now we have directly pushed this into this namespace. Okay, we have copied that here by using this command. Okay, so we have used this command format save. Okay, we have saved inside our cryo image registry, and then we have just copied that image inside our namespace. Okay, so that's it, and now it's working. Although we have other options too, we can do that was the good options, like we can define the secrets. Okay, here inside our, where is this? Yeah, inside our files, configuration files basically. Okay, so here like we have 2 methods. Okay, so here it's only you. Okay, now one method is also here. Let me show you. Create secret to pull images. Okay, so here we can also create the secret. Okay, in the same manner, like we have to provide this, and we have to also change into this file. Okay, so in that manner we are able to do that. Okay, but for now just I have gone through with the tricky one. Okay, so I have done that because yeah, now we have running environment. Okay, so here we have used that our own what we have done till now. So we have actually deployed our by using our image. So we have some more important points here. So like here I have used the cryo environment for directly pushing into the namespace. Okay, so here you can also see that the custom CRD will be also there. Okay, so here we can see that get CRD, and now this time this name will be something I don't know. Okay, create take the name hello operator. And what was the name there inside our application name? CRD that we have defined was something take will be there. Yeah, so it's basically I guess this one, take application web take ej.io. Yeah, so that is the thing. Okay, also if SC Linux is enabled, then we have to do this, because SC Linux RHEL 9.6 is very strict with that. So if your operator need to touch host path like where, log or any other, that container need with the :J or :Z mount flags for a specific SC Linux policies. Okay, and as per system integration perspective, so basically here we have used the cryo, and so your C group driver should match with the cryo.conf. Okay, and here so what we have done, we have initialized the project, we have created the API, we have defined the specs. Okay, and here after that we can just also specify the finalizer. Okay, so that how we can prevent resources from being deleted until the operator cleans. So these all things are happening. Okay, so as here I have once these my two pods are live. Okay, in the same namespace. Okay, so non-working will delete it automatically. Okay, it means it's doing the cleaning automatically by default. Okay, and the other things are like here I have shown you. Okay, and here we can also define the simple logic inside our like internal controller hello app controller.go that I have already shown to you. Okay, how you can do that. Okay, so but here I have not customized that. Okay, so at last we can okay, keep things in mind like our operator creates the resources. If our operator creates the resources outside of Kubernetes like an entry of DNS server or folder or RHEL physical server, if finalizer will prevents the CR from being deleted until that external resource is cleaned up. Okay, because it's essential to pre-delete. Okay, so in multi-node cluster basically, so it can also happen like two operators are fighting for the same resources, so we can define the leader election there. Okay, in such a manner. Okay, so that's all of about the Kubernetes operators. So if you are interested in development part, okay, then you have to learn Go language basically. Okay, so that's it for this video. See you in next video. Thanks for watching the video.